Curve sketching, subsection 2, applying the derivative tests. Part 2, vertical asymptotes. Promise this will be shorter than the last one. Okay, anyways, recall that an asymptote is a line which a graph approaches but never touches or never reaches. Okay, label the asymptote in the diagram below. Well, you guys are pretty bright, so that is the vertical asymptote right there. Vertical asymptote. Okay, and this guy here, that's the horizontal asymptote. I think for these ones, guys, we're just going to call that a VA and an HA. Ha, get it? Ha, nah, not funny, I know. Okay, so vertical asymptote, horizontal asymptote, and we'll go from there. So a vertical asymptote is always located where the function is undefined, and the denominator equals 0. Okay, and the limit as x approaches a from the left is either plus or minus infinity, or as we approach the asymptote from the from the right, positive, and from the left, a negative is also positive or negative infinity. Okay, so what that means is as we approach from the left, this is always going to equal infinity. As we approach from the right, it would equal negative infinity in that case, so positive or negative infinity. Okay, so we did talk about these at length in Unit 2, but we're going to keep talking here. Okay, we're going to expand our values a little bit. Okay, so I want you guys to use your calculator to sketch the graph of 1 over x minus 4. And, okay, we'll just do a really rough sketch of this. So the vertical asymptote we know is at x equals 4. 1, 2, 3, 4. Okay, because we've done this a little bit already. Okay, so where does the asymptote exist? Okay, so x is 4. Well, we didn't finish sketching, so it goes like this, and then like this. Okay, something like that. Awesome. So the vertical asymptote is at x equals 4. How is it related to the equation? Well, of course, it's when the equation, when the bottom, when the denominator equals 0. Awesome. Okay, so let's use our calculator to graph this guy. So when you graph this one looks a little bit different. Okay, we have an asymptote for sure at -5, but then the graph does this. It goes like this and then like that. Okay, clearly going through positive 2. So what's going on? Okay, so where does the vertical asymptote exist? At x equals -5. And then the question is, why is there no asymptote at x equals 2? Well, our calculators don't show it very well. Okay, but remember, we still have to factor the top. So if we factor the top, we get x minus, oh, that's what happened. So x plus 5, x minus 2, the x minus 2's cancel. So really, this is the graph of y equals 3 over x plus 5. Now, the thing is, at x is 2, though, it's still undefined, but because the factor canceled off, we have a hole where that point is. Okay, so it's not an asymptote for that one. The factor canceled off, so remember we get a hole there. Okay, and why is there no asymptote? Because it canceled. The x minus 2 cancels. Okay, great. All right, moving on. Okay, so that's a few examples here, and there are a couple of them, but like I say, I promised it would be shorter than the last one. Okay, so use limits to find the vertical asymptote, sketch the graphs. Okay, so 1 over x, you guys know what this one looks like, but let's follow this through. So we just do this. We go the limit. We know that x can't equal 0. So we know the asymptote is at 0. Okay, we know that. Now, here's what we do, though. How do you know whether it's a swoop this way, okay, and I'll erase those, or is it a swoop this way? How do you know? Okay, now, anyways, so the limit as x approaches 0, and we're going to go from the left. Okay, so from the left is from these. So all the x's would be negatives. So this is going to be 1 over, now as x approaches 0 we get really, really small, right? But it's negative. So we're going to say it's negative small, or very small. Well, 1 divided by a small number is a really big number and a really big negative number. So, hey, that's negative infinity. So that means as we approach this from the left, our graph goes to negative infinity. Well, that means we swoop up this way. Remember, it has no zeros, so it doesn't cross the x-axis ever, so it just swoops like that. Okay, we do the same thing here, limit as x approaches 0 from the right. So that's going to be 1 divided by, well, they're going to be really small numbers, but they're going to be positive small numbers, right? Because on this side, they're all smalls. Okay, sorry, pardon me, all positives. So this is going to be 1 divided by positive small is positive infinity. So it goes like this. Okay, and that's our graph. Awesome. Number 2, so 1 over x squared. Okay, this one we haven't had a lot of experience with squareds on the bottom. So the limit as x approaches 0 from the left. So we're going from the left. So that's negative. So 1 over, so we have negative small. Ooh, but squared. What's a negative squared? Well, it's always positive. Now, a small number squared is even smaller, so this is 1 over positive, really, really small. Okay, which of course is positive infinity. Okay, so as we approach, so it's positive infinity, and again, we don't have any zeros here. Okay, this is the top. The zeros always come from the top, so we never cross the x-axis. So that is a horizontal asymptote. Okay, we do the same thing for x approaches 0 from the right. Well, this is just 1 over positive small squared, which is 1 over positive smaller, which is positive infinity again. So it looks like this. Go ahead and graph it on your graphing calculator if you want, and you'll see that it really does look something like that. Okay, awesome. Moving on. Number 3, a little more complicated here. So we have to factor the bottom this time. So, okay. So x, that's going to be 6 and 2 plus and minus. So x can't equal negative 6 or positive 2, which means we have vertical asymptotes at x equals negative 6 and x equals 2. So negative 6, 1, 2, 3, 4, 5, 6. So negative 6 is about there-ish somewhere, and positive 2 is about there. So those are our vertical asymptotes. All right, so now we go limit as x approaches. Well, now we got to do them for both. So let's start with negative 6, and let's start from the left. Okay, so we're going from this way. All right, so numbers like this, that's going to be like negative 6.1, 6.01, 6.001. Okay, so when I have those numbers, so I get 4, because that's never going to change. So negative 6.001 plus 6. So that's going to be a negative small. Okay, negative small, and then negative 6 minus 2 is going to be negative 8. So negative 8. Okay, and if you look at this, we've got 4 over a negative small and a negative 8. So negative small times negative 8 is going to be a positive. So this is going to be 4 over positive small. Oh, well, that's going to be 4 over really, really small. Anything divided by small, that's the positive infinity one. So as I approach this is going to be the positive infinity. And it's going to swoop along and go. Okay, because we have no x-intercepts, because the x-intercepts, remember, come from the top. So that would mean the top equals 0, well, 4 never equals 0. Okay, so we have a swoop like that for that one. So then we go the limit as x approaches 6 from -6 from the right. Okay, so that's 4 over. Okay, well, as I approach this way, so numbers now are going to be like -5.9. Okay, 5.99, -5.999. Okay, well, -5.9 plus 6 is going to be a plus small. Okay, and then -6 minus 2 is still -8. Okay, so anyways, this is going to be 4, a negative small times -8 is going to be a negative small. So this is 4 over negative small, which is negative infinity. So look, this one is going to go negative infinity and kind of go up like this. Okay, now we'll attach them here in a minute. Okay, so then we have the limit as x approaches 2 from the left. Okay, so we have 4 over as x approaches 2. So these are numbers like 1.99. Okay, so 2 plus 6 is positive 8, and like 1.99 minus 2, it's not quite 8, right? It's like 7.99. Don't worry about it. It's that part's not important. Okay, it's the -2 part. So 1.99 minus 2, hey, that's negative small. Well, if that's negative small and the other one's just positive 8, well, this is negative infinity again. Oh, look, so that one's negative infinity, so that comes in swoops, and we just, for now, we just attach them. Okay, don't worry too much about where they meet up, they just do. Okay, that's good enough for a sketch for right now. And then, of course, the limit as x approaches 2 from the right. Okay, that's this way. Okay, so that's numbers like 2.01. Okay, 2.001. So anyways, we get 4 over, well, 2 plus 6 is 8. But 2.01 minus 2 is a positive small. Okay, well, that's going to be a positive infinity. So now we're a positive infinity way up there. And we swoop down like this. So that's our graph. Fantastic. Oh, looks like that again. Okay, there we go. Okay, we're closing in on it, everyone. Okay, so last one. Again, we factor the bottom. Okay, so x, so 16, so we need 8 and 2, plus and plus. Okay, so if you have a quick look at this, oh boy, the 2's cancel. So x still can't equal -8 or -2. But the vertical asymptote now is at x equals -8. 1, 2, 3, 4, 5, 6, 7, 8. So about there. Okay, so there's our vertical asymptote. No biggie. So we go to the limit as x approaches -8 from the left. Okay, well, really, this thing just simplifies to 1 over x plus 8. So -8 from the left, so those are really big negative numbers. So like -8.1 or something like that. So anyways, this is going to be 1 over negative small. Terrible writing. Okay, so negative small, which is negative infinity. So it's going to go like this. Okay, and then the limit as x approaches -8 from the right. So that's like -7.9. So -7.9 plus 8 is a positive small. So that's going to be 1 over x plus 8. 1 over positive small, which equals positive infinity. So positive, so it goes like this. Now, remember what happens here is at -2, there's a hole. Okay, so if we actually type that in, so -2, so what happens here? We get 1 over x, so x would be -2 plus 8, so that's 1/6. So this guy here would be -2 1/6, and that's where the hole is, because we're not allowed to equal -2, and so then the y value won't equal negative, or positive a sixth either. Okay, so that's the whole, and away we go. That's it for part 2. Thanks.